ఇలా start.
అప్పుడు పెళ్ళైనప్పుడు తర్వాత ఇక్కడే ఉన్నాడంటే కూడా
Hello.
Hello. Yeah. Hi.
Yeah. Hi.
Hi. Good afternoon.
Good afternoon.
So I sent some limits questions, right? In that there are some different type of questions are there. Okay.
Oh, sorry, I didn't know.
Okay, I sent
I'll
your
ask
father.
my father to-
Okay, just
yeah.
ask your father.
Okay,
to
I'll check.
send.
Yeah.
Okay. We were dealing in maths about the differentiation, right?
Yeah, sir.
First, as a reason, tell me the formulas which we did till now in differentiation.
First hand formula, then for x raised to any like n power, and
You have to
of a
tell the
constant.
total formulas.
Oh, total formula. F
The
of
first
x
hand
is
principle.
yeah, first hand principle. F dash x is equal to limit of x tends to 0, and f into x plus h minus f of x by h.
Here is it x tending to 0 or h tending to?
No, h tending to 0.
Okay, next.
Then differentiation of x to the nth power is equal to x n into x raised to the power n minus 1, and differentiation of a constant is equal to 0, and then the differentiation of u plus v is equal to u dash plus v dash, and differentiation of u minus v is equal to u dash minus v dash, and differentiation of uv is equal to u dash v dash plus u v dash. No, sorry, u dash v plus uv. Yeah. Plus, yeah, uv, yeah, and then what else? Yeah, and then differentiation of u by v is equal to u dash v minus u v dash by v squared.
This is the quotient rule, they will call the name of it.
Yeah.
That's
Okay.
next, we
And-
studied about the same thing, the chain
Yeah,
rule
that
we
is okay.
studied.
Oh yeah, chain rule also.
And in the previous class, we studied about the trigonometry, right? Differentiation
Yeah.
of trigonometric functions. So first, differentiation of sine x.
Cos x.
Cos x. Differentiation of cos x
Oh, minus sin x.
minus sine x. So these two are pretty simple to remember.
Yeah.
Differentiation of tan x.
Secant square x.
Here we have a secant square x. Next, differentiation of secant x.
Secant x into tan x.
Differentiation of cosecant x.
Minus cosec x into cot x.
Differentiation of cot x.
Minus cosecant square x.
Okay. These are all the formulas which are in this one. Next, let us suppose if I include this one. What is the differentiation of ax plus v to the power n?
That'll be a into n into x raised to power n minus 1.
N into
A into n into x raised to power n minus 1.
like this.
Yeah.
Okay, tell me what you have used over here.
Because b is b a constant
Yeah, b is
to
a
the power. It has
constant.
no variable. Yeah. So that differentiation of a constant is equal to 0.
Okay.
So it's basically
Then
just differentiation of ax, which is nothing but a into n into
but
x raised to power
there
n.
is power n also, right?
Yeah, that's what differentiation of ax to the power n, right?
Then you are eliminating
Okay. So
b.
even it's a to the n. Okay. So it'll be a to the power n into n into x raised to n minus 1. Is that it? Oh, okay.
Here ax plus b is one total function.
Yeah.
The
Right.
total function to the power n, right?
Yeah.
So what it will be?
So ax plus b to the power n into
This
differentiation of
total, if you differentiate it, it becomes n into ax plus b, right?
Yeah.
Multiplied by
Into
the differentiation of this.
yeah.
That is
Ax plus b.
differentiation of ax plus b.
Ax plus b.
N into ax plus b, and the differentiation of ax plus b is a. So you have that n a into n into ax plus b. Okay. So in general, you're thinking like how this different, what is this chain rule under, how it got the name. It is same as like this. What you're taking is, this is one different function, right? Then this total is one function. So
Right.
you are considering this the inside function as u. Then it becomes u to the power n, right?
Yeah.
This is one function. We are considering this total as v. Okay.
Okay.
Means now we have two functions. First is du with dv and dv by dx.
D.
Okay.
Okay.
Here the v is the bigger one. So here u dv. First you are doing dv by du, right? This is v
Right.
is equals to u to the power n, correct?
Yeah.
If you do dv by du, you will get n into u, correct?
Right.
This one. And again if you do du by dx, u, that is which is inside one, ax plus b. Okay.
Okay.
Differentiation of ax plus b directly with respect to x. You are getting it as differentiation of ax plus b with respect to x. It is a itself. So if you are, here you are multiplying it, n into u is nothing but ax plus b to the power n minus 1 into a. The same thing here you are doing directly, that's it. Here we are just describing that. Once you know how to do it directly, then no need of this. Directly you can proceed.
Okay.
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 Now, what is the differentiation of sine 4x plus 5?
So is it equal to cos 4x?
Okay. Now let's see. Here it is sine of 4x plus 5, right?
Right.
We have the
Yeah.
formula for sine x,
Yeah.
right?
Yeah.
But instead of x, we have another function, 4x plus 5.
Right.
Okay. So here
Okay.
we will proceed by the descriptive way of this chain rule. What I will do is I will assume this as v, like v is equals to the total function and u as 4x plus 5. Okay.
Okay.
This becomes v equals to sine u, right?
Yeah. Yeah. Yeah.
I am taking this 4x plus 5 as u. So v equals to sine
Okay.
u
Yes.
and
I knew
u.
that.
As chain rule,
Into
I have to get dv by dx. This is the n term I have to do. So dv by du, if I multiply by du by dx, I can get dv by dx, right?
right.
Now first I will do dv by du. So dv by du is nothing but differentiation of sine u. What is differentiation of sine u? Cos u.
Or
Okay,
cos
we'll
u.
write cos u into, what is du by dx? U equals to 4x plus
U
5
by.
dx. The differentiation of 4x plus 5 is 4, right?
Right. Yeah.
To 4. So what is cos? What is u over here?
4x plus 5. Right.
Into 4. This is the answer. Okay. Here why, how we are doing this, I will explain it directly. Here sine of x is there, then it's okay. We can directly write cos 4x. Okay.
Okay.
But here we have sine of 4x plus 5. Means here we have a function and another function. Here there are two functions, right? One is a
Right.
sine function. Another is 4x plus 5. It is also a function. There are two functions. When there are two functions, always you have to use sine rule. Okay? Not sine rule, this chain rule. Sorry. Whenever there are more than two functions, you have to use chain rule. Correct?
Right.
And in chain rule, as I told before, you have to go from outside to inside. Means first you have to take the outside function. Next you have to go inside and you have to differentiate the inside function. Okay?
Okay.
When you are considering this outside, it is in terms of sign. Whatever inside is, this total becomes one variable x. Okay?
Okay.
It doesn't matter how many there may be two or three functions within itself. It doesn't matter to us. When you're seeing from outside, there is only one function, that is sine. That's it. Okay? Now,
Okay.
what is the differentiation of sine of anything? It is cos of that, right?
Yeah.
So we will write cos of whichever is inside, that's it, 4x plus 5. Now the outside function derivation is completed. Now we have to go for inside. Now we have the inside function as 4x plus 5. Do the differentiation of inside function.
It's 4.
That's 4. That's it. 4 into cos of 4x plus 5. That's the same as this.
Okay.
We will do problems like this. So what is cos of x square? Here you have to say this differentiation d by dx of cos x square. Okay?
Okay.
Cos x square. So remember one thing, there is a difference between cos square x and cos x square. There is a difference between two. Okay? They are not equal.
Okay.
Okay? And
Okay.
this cos square x, you can write it as cos x whole square. Okay?
Okay.
These two are same. But cos square x is not equal to cos x square. Here the square is for only this x, means only for the angle. In the above one, the square is for the total value. Okay? That is cos x. For the total value, it is the square. Okay?
Okay.
Now, first you have to know that you have to see the difference, whether it is cos square x or cos x square. Now it is cos x square, right?
Yeah.
So here cos is one function, x square is one function, right?
Right. Yeah.
If it is just d by dx of cos x is not a function. Cos x is one function. Okay?
Okay.
Then directly we will write minus sin x. But here it is cos of x square, means there is one function, second function. Total there are two functions, correct?
Right.
So when there are two functions, just you have to proceed with chain rule. First you have to do the differentiation of the outside function, that is cos of this total function, right? Now,
Right.
what is the differentiation of cos x square? Just see this cos, that's it. Differentiation of cos is
Minus sign.
minus sin x square as it is, right?
Yeah. Yeah.
Now you have to go inside. So now this cos is completed. Now going to inside function. Inside function is x square, right?
Right. Yeah.
Now we will do differentiation of x square into
2x.
2x. Now are there any other
Oh.
functions? That's it,
No.
right? This is the answer. Minus 2x sine x square. Understood?
Okay. Yeah.
Now do the differentiation for this one. Cos square x. Here when you see cos x, okay. Just to avoid confusion, we can write cos square x as cos x whole square, correct?
Right. Yeah.
Now, here also there are two functions. First is the power function, like x to the power n. It is also a function, right?
Right.
So first, this is the, always I told you have to go from outside to inside. Outside is the power function. Inside we have
Right.
cos function. That's it.
Faster. Yeah.
So first do the differentiation of the outside function, that is power function.
Okay.
So this total becomes as one variable to the square. So what is the differentiation of this one?
2 cos x.
2 cos x as it
Cos
is
x.
into. So differentiation, now come to inside. Differentiation of cos x
Minus sin x.
minus sin x. This is the answer. That's it. Minus 2 sin x cos x. Okay.
Okay.
Understood how this chain rule works
Yeah.
in trigonometry? Not in trigonometry, in everything. Just you have to identify what are the different functions are there. Okay.
Okay.
Now this one. What is the differentiation of 2 tan square x?
So tan square x, we can address tan x to like the whole square, right?
Yeah, we can write, so d by dx of 2 into tan x whole square. Okay.
Uh, then, so first we differentiate 2, right?
Okay. As I told before, whenever the constant is multiplying with any function, just take it out.
Oh, okay.
It is not in addition, right? If it's addition, you will take the
Right.
differentiation of it. As we discussed before, same thing. Differentiation of a into x to the power n. Just you are taking a out. Differentiation of x to the power n. That's it.
Okay.
Okay. Means you are taking this
Okay.
constant outside because it's in multiplication. So
Right.
2 d by dx of tan x whole square.
So is the answer 4 tan x into secant square x?
Yes, 4 tan x into secant square x. Okay, understood?
Yeah.
Now, this one. 1 by 2 secant of x by 2 minus 1 tan of x by 2 minus 1 differentiation d by dx.
Okay.
Here the first thing is you have to take the constant outside. It is of noise. Just you have to multiply it out. That's it.
Okay.
Means you have to do differentiation of only this.
Right.
Here there are 1, 2, 3, 4. There are 4 functions. What to do?
So do we like first do uh, I don't know, like in which order do I like go in?
Oh, you know this one. So when we are discussing chain rule, okay, we are doing the
Okay.
outside one first. Next you are going for
Right.
inside. Next you are going for inside, 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 right?
Right.
Secant of this is one quantity, this is one entity, right? This is in
Right.
multiplication. That's it.
Okay.
This is u, this
Okay.
is v, u into v.
Okay.
Differentiation of uv, u dash v plus uv dash.
Right.
While doing the differentiation of this, we will use chain rule because there is a secant function. Inside we have x by 2 minus 1 function. There are only two functions, that's it. First function, second function in u. First function, second function in v. Always we will use chain rule when there is a function inside a function. Okay?
Okay.
Here the two functions are multiplying. That's it. If it is like this, let us suppose, okay, see this one. Observe the difference between the next question that I am writing. Same thing, half of secant of x by 2 minus 1 plus tan of x by 2. Okay? If it
Okay.
is like this, means in the secant function we have two functions, right? X by 2 minus
Right.
1 and tan x by
Yeah.
2. Here you have to use, first you will do the secant one, next we will come to the inside function. And when this is the
Okay.
total inside function, so first you will do x by 2, next for minus 1, next we will do tan x by 2. Okay?
Okay.
Okay, we will do this both side by side, and let's observe the difference between the two. Half of secant of x by 2 minus 1 plus tan x by 2. Okay? Observe the difference between those two. Here, secant of theta, right? In the whole theta, we have x by 2 minus 1 plus tan x by 2. This total
Right.
thing is theta. In this, this is
Okay.
just the theta. In this is just the theta. There is multiplication, right?
Right.
Now, we will do the differentiation of this first one. Then we will do for the second one.
Okay.
Not differentiation of the first. So take this half outside. Not necessary. This is
So
u,
that'll
this
be
is
all.
v. So first
Right.
u dash.
Yeah. So wait,
Differentiation of,
is the wait u dash is only the x by 2 minus 1, or is does it include the secant also?
no, this
The whole
total
thing,
is
right?
u. The whole thing is u.
Okay.
In that we have this, we have to apply chain rule because there are two functions.
Okay. So can I write it as secant x by 2 minus 1 into tan x by 2 minus 1
Because we know the differentiation of secant is secant x
into tan?
tan x. Here the x is same. You should not write the x itself. This is the x over here. That's why you're writing x by
Okay.
2 minus 1. That is u
Yeah.
dash. But it is just only for secant x. There is a second function that is x by 2 minus 1 also.
Right.
Now the
Oh,
differentiation of
okay.
x, the inside function. This is the differentiation
Uh,
of outside function, that what we have
right.
written. Now we have a differentiation of inside function. What is differentiation of x by 2 minus 1?
One. So is it just one?
X by 2 minus 1. Differentiation of this, it becomes 0, leave it. Differentiation of x by 2, right?
Right.
1 by 2
So I
is
can write as x raised to the power minus 2, right?
1 by x square, you write as x to the power minus 2. It is
Oh,
x
okay.
by 2, that is 1 by 2 into
Right.
x, correct? So we can
Right.
take 1 by 2 outside. So 1 by 2 into
Yeah.
differentiation of
So
x, that
1
is
by
1 by 2. So
okay.
into 1 by 2. Okay.
Okay.
Now that v as it is, it will be there. Now the v the same. I will write v in red color. tan of x by 2 minus 1. This is u dash v, correct?
Yeah.
Plus u as it is secant of x by 2 minus 1. Now we have to write v dash.
So it's tan x, right? So that's secant square and x by 2 minus 1.
X by 2 minus 1. This is the differentiation for outside function. Then you have to go
Right.
for inside and you have to do here also.
Okay. So
So
it'll be the same thing, right? 1 by 2.
into 1 by 2. That's it. This is the differentiation for the above one. You have to see what are other functions. Are there any function which is inside a function? That's it. Okay.
Okay.
If it is x minus 1 also, it is a function. You should not take only when there is x. Okay.
Okay. Okay.
If it is x minus 1, x square, x by 2, anything is different function. We have to consider it as another new function. This is
Okay.
the answer for the first one. Now tell the differentiation for the second one. For this. What we have to do?
So that's
So
the
half as
whole,
it is.
right?
So leave it.
Yeah. So do I
So
have to
now,
take
yeah, this
secant?
whole thing as x.
Okay.
Because this whole thing is the function in theta, right? It should be theta,
Right.
but there are many other functions. We don't care whether there are any number of functions. It doesn't matter to us. You have to take the total thing as one variable. That's it.
Okay.
While
So
doing
that's half
differentiation.
in. So
Tell me.
half into secant of the whole thing into tan of the whole thing.
So half into secant. Yeah, because the secant takes tan x, right?
Yeah.
Secant of this one and tan of this one. Okay, next.
Uh, and then I do a differentiation of each, right?
Yeah, into differentiation of
Okay. So
this inside
yeah.
function. There is
So
multiplication. You
is
have to.
x by 2 minus 1 is like 1, right? Function.
Yeah, you can just eliminate. Yeah, x by 2 minus 1 as one
Okay.
function.
So that's 1 by 2 into 1 by 2
That's
plus
1 by 2
secant square of x by 2.
plus secant square of x by 2. That's
Yeah.
it.
Yeah.
In tan x by 2 also we have two functions. Tan x by 2.
Oh,
Tan x
okay.
by 2 is secant square x by 2. Then differentiation of x by 2.
X
Again
by
into
2.
1 by 2.
Right.
Right? You have to see
Right.
all the
Okay.
functions which are inside also.
Okay.
This is the differentiation for this. Okay?
Okay.
No. Minus 3x square into sine 3x plus 4x into cos 3x. Differentiation of this. The only thing you have to identify is which rule you have to use. Okay?
Okay.
When there are two functions,
Yeah.
which is plus, it is u plus v. Okay, one thing is clear, you
Right.
have to take this separately. So, right, we will write first that one. Differentiation of minus 3x square sine 3x plus differentiation of 4x cos 3x. Okay, this rule applied. Now, when you see this, when you come to this first function, we have minus 3x square sine 3x, right?
Right.
Means you can take this minus 3 outside, so that not necessary. So it is x square sine 3x. Means the x square is one function, into we have sine 3x, another function. Right?
Okay.
So this
Yeah.
becomes uv, u into v. Then we will apply u dash with it. Now it will come same thing, 4 outside. It is x into cos 3x. Same
Cos
thing,
3x.
uv rule. So first, take this minus 3
So when
outside.
it's okay.
Yeah, tell me.
No, so can you like multiply the functions with each other?
Like 3x square into sine 3x.
No, like 4x into cos 3x. The 4 goes out, right? So can you like multiply the x with 3x?
No. X is one function, cos 3x is another
Yeah.
function. Here 3x
Okay.
is inside. You can't send x to this one. Okay.
Okay.
X is one boundary. Cos 3x is one boundary. You can multiply anything within the boundaries, not outside the boundaries. Okay.
Okay.
If it is like cos 3x, in the bracket itself, if they tell plus 4x, this total thing is one boundary, right? Because cos of this theta.
Right.
You can add these two or multiply these two depending upon the sign. But when there is x over here, this becomes separate boundary. You can't send this x to inside. Okay.
Okay.
Actually, so cos 4x into cos 3x. So first minus 3 as it is. So first I will let the next step. Differentiation of x square sine 3x
So it's
plus 4 into differentiation of x cos 3x.
right.
Now the next step, minus 3. Differentiation of x square sine 3x. It is in multiplication, correct? We will use uv rule.
So your voice is breaking.
Just a second.
Okay.
So tell me what is the next step?
So what? I can't hear you.
Yeah. Next step.
So what?
Wait. What will be the next step?
Oh, okay. So that's minus 3 into 2x into sine 3x plus 4 into cos 3x.
First finish this one.
So that's it, right? It's u into v, right? Yeah.
U dash v plus uv dash.
Wait, what was it? Oh, okay. Sorry. So it's x squared into function of sine 3x. So that's into x squared into
Plus x
cos
square.
3x. Sorry, plus x squared into cos 3x.
That's it.
Yeah. And then plus the rest.
What is differentiation of sine 3x?
Cos 3x.
As I told before,
Okay.
if it is just x,
Yes,
then it is a
okay.
function. If it is
Yeah.
3x, x by 2, x plus, it is a different function, right?
Right. Yeah.
So it becomes cos
Um,
3x, then the differentiation of 3x,
into
that is
yeah,
into 3.
3 cos 3. Okay.
That becomes 3 cos 3x. Then this is one thing. Plus Next one.
Plus 4 into cos 3x.
This one. U, V.
Yeah.
Hmm.
Yeah, 4 into cos 3x plus into 4x, and differentiation of cos 3x would be minus sin x, right? Yeah, minus 3x. So 4 into 4x
4 I have
into
taken
3.
common.
Oh, okay. Into minus 3 sin x. Am I right?
Yeah.
Okay.
Just have taken 3 outside. That's it. So that's it.
Yeah.
Then we will simplify it. Okay.
Okay.
So the main thing is writing from this step to this step. You have to use the UV formula and you have to use the chain rule both at once.
Okay.
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 Sine of 3x square plus 4x plus 1 divided by cos of 5x.
Okay. This is me. So first it will be differentiation of sine of the whole thing, right?
Yeah, it
When
is
I
of u
write
by
it.
v. Yeah, that's
Yeah.
it.
Um, so when I write v square, it's cos square 5x, right?
Cos square 5x or cos 5x whole square. You can write.
Whole square.
Let's say, yeah, what it is cos square 5x also you can write it.
Okay.
Denominator is pretty simple, just you have to put square. The only thing is for the numerator.
So can I just substitute the whole 3x plus 4x minus 1 as like some like theta or something?
Yeah, that because this
Okay.
total is 1 theta. Then it becomes
Right.
differentiation of sine theta.
Yeah.
Then you have to come inside and you have to take this one.
Right. Sir, is it cos theta for the first term?
Okay, cos
Cos
of,
theta,
okay,
the whole thing,
hmm.
into 6x into 4
6x,
into 4.
y into 4, tell me.
Oh, sorry, plus 4, sorry. Into 6x plus 4 plus 0, and into cos 5x. That's for like the first term.
Okay,
Minus sine theta
okay,
into differentiation of cos 5, right? So that's 5 minus sine 5x.
that's it. The whole divided by cos 5x
Yeah,
or cos square
whole square.
5x.
Yeah.
That's it. Okay. No.
Okay.
Now I will include 3 functions within itself. Let's see. This one.
Okay.
Just a second.
Okay. So first, I differentiate the sign this, right?
Yeah,
Okay.
it becomes
So it'll be cos 4x square plus cos cube 4x, right?
okay. Next,
And then into so now each term, right?
means differentiation of the inside one.
Yeah. Okay.
Hmm.
So it's 8x plus cos cube 4x. So how do I like write cos cube 4x?
Same thing, cos 4x whole cube. That's it.
Oh, okay.
Anything this power over for the cos, you can take it out and keep it for the whole. Okay.
Okay.
Okay. Just for a change, 1 second. 4x square.
Okay.
It may look very complicated, but it is not.
So it'll be 4 into minus 2 sine 4x, right?
Let's see.
Is that right?
First, just a bit of modifications we have to do for that. Let's see.
Okay.
So it is cos 4x square whole cube, right?
A cos for, yeah.
I have included square also. Same thing. So whole
Okay.
cube, correct?
Yeah.
What is the differentiation for this? We know directly 3 into cos 4x square whole square, right?
Yeah.
Because this total becomes one function. This is the power function, right? So that's why n into
Yeah.
x to the power n minus 1. So this one
Right.
gone. Now we are in cos 4x square. So now this square is gone. Now we are in cos 4x square, right?
Right.
Into what is the differentiation of cos 4x square?
Oh, minus 4x. Oh, no, sorry. Wait.
Minus sine. Minus sine 4x square, right?
Yeah.
So now cos function gone.
Yeah.
Now we are in 4x square into.
Right.
What is differentiation of 4x square?
4, I can take, so 4 I can take it out, right?
Yeah, 4 you can take it out.
So 8x.
8x. That's it.
Okay.
This is the chain rule. Means you are eliminating one by one function by one function, by in a chain procedure. Then at the end you will get to one answer. That's it. Okay. In the same way, they can give any number of functions. It doesn't matter to us. Just what you have to do is you have to go from outside to inside. One function by another function, and you have to do differentiating. That's it.
Okay.
Now, just one simple one. What is cos mx minus cos nx? The differentiation of this.
So 1 second. So this is u minus v, right?
Yeah.
So I'll just write it. Uh, so first I do the whole cost differentiation of this, right? So minus sine mx, right?
Yeah. Minus sine mx.
Into 1, right? Because it's differentiation of x.
Mx is the function, not
Oh,
x.
okay. So into m, right. Nx. So is the total answer minus sine mx into m minus sine nx into n?
So what will be in the end?
Minus sine m square x minus sine n square x.
How are you getting m square?
Oh, can I multiply the n with sine nx?
As I told, n
Oh, it's two different.
cos
Yeah.
nx. There are two different. You should not multiply.
Okay.
Okay, this total is one entity. N is a different function. You can't multiply
Okay.
them. You can multiply a function with a function. That's why you're multiplying n into cos nx. But you can't
Right.
multiply a function with an input of a function. Here nx is the variable, that is input of a function, right? You can't multiply
Right.
both. You can multiply
Okay.
function with a function.
Okay.
So here it becomes as plus, right? Because minus of
Yeah.
minus, it becomes plus n sine
Sine
nx.
nx. Right.
So it total becomes as n sine nx minus m sine mx. Correct?
Yeah.
What is the differentiation of this again?
Differentiation of this.
Yeah.
So
Second derivation.
this will be again u minus v, right?
Yeah, again u minus
So
v.
yeah. So I don't know how to like write this.
No, it's the
Is it
same.
n
Now,
into cos x?
yeah, that's it. You're doing the, now
Okay.
instead of this total one, this is the function you got. That's it. Now you're
Right.
differentiating this one. So differentiation of n sine x minus differentiation of m sine mx. Right here, m sine nx. So now it's the same thing. N is common. Take it out. Differentiation
Right.
of sine nx is
Sin nx will be cos nx.
differentiation of sine nx.
Oh,
You have to tell total at
okay.
once.
Yeah. Okay, so cos nx into 1, right?
Into,
Oh no, into n.
yes,
So
it
n cos
becomes as
nx.
n
N
cos
cos nx.
nx. So into n cos nx. Okay.
Yeah.
Minus. Now differentiation for, so m is constant. We have taken it out.
Right.
Now differentiation of sine mx. Tell directly.
Yeah. M cos mx.
So
M into
m
cos mx.
cos mx. So the total, what it becomes? N square. Now it is n into n. An input with an input.
Okay.
N and n two different.
Right.
So n square cos nx minus m square
square cos
cos
mx.
mx. Okay.
Okay.
Now, after this, so now we are pretty much decently sure about how to do differentiation. Not pretty much, we know how to do, just as a matter of practice. That's it. Now we know how to do any number of functions, whatever the functions they may give, and how many functions they have included in one function. We can do it. All right.
Okay. Yeah.
Now, after knowing this differentiation, now again we will go back to the limits. I told before there is one particular rule for finding the limits directly by using L hospitals. It's called L hospitals rule.
Okay.
So what this L hospitals rule states is that if you want to find any limit, let us suppose, okay, same thing, limit x tending to 0, the same function, cos mx minus cos nx divided by x square. This is the function. Okay. Now, how to find the limit for this?
I can write it as limit of x tends to 0 cos mx minus cos nx divided by limit x tends to 0 of x square, right?
If you substitute, it comes 0 by 0.
Yeah. But
It is 0 by 0
I
form,
don't know
right?
how to. Yeah. In any method, it's 0 by 0, right?
In any method, it is 0 by 0. Means we have to manipulate
Right.
it. Instead of cos mx minus cos nx, we have to write in different way, that is in standard form. We studied the standard forms as limit x tends to 0 sin x by x, right?
Right.
Same thing, we have limit x tends to 0, 1 minus
One.
cos x by x.
Yes.
This one we derived. Actually, this one is not in textbook. This 1 minus cos
Okay.
x by x is 0.
This
This
is
is
equal to
1.
0. 1.
This is 1. Either you can convert this to sin x by x. But in maximum cases, we will take it as sine forms only. Okay. Means you have to convert this total cos mx minus cos nx into sine forms. For that, we have to know what is, so mx, I can take it as total 1a, right?
So can you just give me 1 minute? So just 1 minute.
Yeah, okay.
Yeah, sorry, sir.
So no.
Yeah.
So here it is of the form cos A minus cos B. Okay.
Okay.
Now we have one formula for it. What is cos A minus cos B? Remember?
No.
Okay. So cos A minus cos,
Oh, is
okay,
it
we
is it
will,
limit of cos A minus
no,
limit of
wait. It is same as A is nothing but mx, right? If you substitute A as
right?
mx, it comes as again the same form itself. There is no change. So
Okay.
when we are studying this trigonometry, these are the most important identities. Wherever you see this form, you have to substitute it with another one. Just converting from one form to another form. That's it. Okay. So here
Okay.
cos A minus cos B, you can write it as 2 sine of, okay, I will
Oh,
write it as
minus.
B plus A.
Wait.
I will write it as B plus A.
Okay.
B plus A by 2 into sine of B minus A by 2. I can write as A plus B by 2 also, but just for the remembrance of B minus A, I am writing B plus A by 2.
Okay.
These are called the compound angles.
Angles, yeah.
Okay, cos A minus cos B, we can write it as 2 sine of B plus A by 2 sine of B minus A by 2. Okay.
Okay.
Now, if you substitute cos mx and cos nx like this, first we will do the normal limit method. How? So limit x tends to 0, cos mx minus cos nx whole divided by x square. This is the question.
Right.
So what is the formula? Mx I am taking as total one angle because it's in angle position. Cos A minus cos B is equals to 2 sine B plus A by 2
Right.
sine B minus A by 2. Correct?
Right.
Now I will substitute in this. So limit x tends to 0. Cos mx minus cos nx becomes 2
2 sine
sine. Tell me what it becomes.
mx plus nx.
So nx plus mx by 2, all right,
Yeah. Yeah.
into
Into sine
sine
nx minus
nx
mx.
minus mx by 2, right?
Yeah.
Whole
Yeah.
divided by x square. Okay.
Yeah.
So now if I look it thoroughly, I can write this one as 2 into sine. There is xx common, right? Sine.
Yeah.
So x n plus m by 2 sine same x common n minus m by 2, right?
2. Right.
I can divide this, write this x square as by x by x, right?
Right.
Now, if I compare this one, it is somewhat like sine x by x, right? If it
So I
should
can't
be
hear you.
a, if here if it is a, here it should be ax,
Right.
right?
Right. Yeah.
Now just we have to make it in that way. That's it. So for that, what we will do is, in the place of a,
Okay.
what we have
N plus m
n
by 2.
plus m by 2. Just we will multiply and divide with n plus m by 2. Okay. Here also n plus m by 2. In the numerator we have n plus m by 2. Okay.
Okay.
Now for the second one, it is n minus m by 2.
Yeah. So we do it
So
with
n
n minus.
minus m by 2 into n minus m by 2. Right.
Yeah.
Now if I apply limits, this is of sine ax by ax form.
Right.
So this total becomes, so 2 into,
1.
what is the value of this total? 1 into,
1.
again limit extends to, this is sine ax by ax form. So 1
Yeah.
into n plus m, they are constants, right?
Uh,
N plus m and n minus m.
yeah.
So what is n plus m and n minus m? N square minus m square by
By
4.
4.
So 2 gets cancelled. So we get n square minus m square by 2.
2.
So for this we have to remember this whole thing and we have to do, right?
Right.
In the end we are getting n square minus m square by 2. Now let's see this in another method. Limit extends to 0, cos mx minus cos nx divided by x square, right?
Right.
What this L hospital rule says, it states it very clearly. If after applying the limit, okay,
Okay.
if it is of the form 0 by 0 or in any indeterminate forms like infinity by infinity also, okay, any indeterminate forms, okay,
Okay.
differentiate the numerator separately, differentiate the denominator separately, okay,
Okay.
until and unless you are out of these indeterminate forms, or You should not get indeterminate forms after applying the limit. Okay, let's see this, what this is. So it is of the form 0 by 0, right?
Right.
Now we will do differentiation of numerator and denominator separately. It is not the differentiation of the whole function. Differentiation of numerator separately, differentiation of denominator separately. Okay.
Okay. So I
Now
can't hear you.
you have to do differentiation of numerator separately,
Okay.
differentiation of denominator separately.
Okay.
What is the differentiation of numerator? Same thing, right, as it is, limit x tends to 0.
Differentiation.
What is the differentiation of the numerator?
That's u minus v, right? So
That we did over
minus.
here. All right, this one. Same thing, cos mx minus cos n. How much we got?
Yeah.
M minus
Sin.
m. This one,
Sin
n sin x minus m sin mx, right?
Right. Yeah.
So directly m, it is n. N sin nx minus m sin m. This is the derivation of first numerator.
Right.
Divided by. What is the derivative of denominator?
2x.
2x. Now substitute 0. Again it is of the 0 by 0 form.
Yeah. Yeah.
Then again do the differentiation.
Oh, so
What is the
we have to keep doing
differentiation?
it until it's not.
Yeah, until it's not in
Like 0.
indeterminate form.
Oh.
Now what is the differentiation of the numerator?
Will be n cos nx, right?
We did it in previous slide also. You have to tell. I won't show. N sin nx.
Right.
Differentiation of this. So take n outside. Differentiation of sin nx.
Cos. Oh, yeah, cos nx into n. Sorry. N.
That's what I want. Remember,
N
keep
cos
this in mind. Cos fx means m minus m sin mx. That's it. You should not forget this m. Okay.
Yeah. Okay.
Now, this becomes as n square cos
Cos x.
nx, not x, nx.
Oh, yeah. No, so. Oh, yeah. N cos nx. Right.
Right?
Yeah.
Now minus, same, the limit is that limit x tends to 0. What is the differentiation of m sin mx?
M into m cos mx.
That becomes as m square
Square
cos
cos mx.
mx divided by differentiation of 2x.
2.
2. Now substitute 0.
Oh, okay. So that's 0 by 2, right?
0 by 2. So cos, if you substitute n as 0, it becomes cos 0, right?
Yeah.
What is cos 0?
Oh, cos 0 is 1.
1, not 0.
Right.
Minus m square into 1 by 2, right?
Right.
N square minus m square by 2.
2.
This is the same thing we got. Okay.
Okay.
Whether you can use this L, actually it is not in the syllabus, remember. Okay. But you have to use this for, you can use this for checking purposes. The main use of this L hospitals rule is in competitive examinations. That's it.
Okay.
And the secondary usage of this is you can check whether the limit that we have calculated is correct or not.
Okay.
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 So, okay. That's why we studied this L hospital's rule at the end after the derivative, because it includes derivatives in it. Okay.
Okay.
Now, this is in the derivative part. Now, in next class in maths, we will do the limits itself.
Okay.
But all we have studied
Using
with
this.
limit x, yeah, using this one is just simple. Just if you know derivative, there is no need of doing this one, right? It is just
Right.
practicing of derivatives. That's it. In simpler words to say.
Okay.
Now, we will do derivatives also, but till now we studied limits, which is x tending to 0, right?
Yeah.
Now, what happens when limit of x tending to some any other value like a or pi by 2 of sine of x like this, okay, or sine of x minus pi by 2 types by x minus pi by 2. Here we know the answer directly is 1 itself. Okay.
Yeah.
Here we have to study, means instead of using the 0 as a limit tending to 0, what happens if they give another value? That's it. The procedure is
Okay.
same what we are doing, just there is some one formula for substitution. The same formula is used for finding whether the limit exists or not. Okay.
Okay.
We studied whether the limit exists or not depending upon left hand limit equals to right hand limit, right?
Right. Right.
Left hand limit, right hand limit, it becomes easier when they give a normal functions, and on substitution
Right.
we'll draw a table, we'll substitute it, we will take two values from left side, two values from right side, and the value itself, then we will
Right.
similar to they are equal, so they exist. That is one thing, right? And the
Right.
other one, and the other thing is when they have given the graphs in graphical notation, we will see the graphs they are asking, we will see the left side of it, right side of it. Okay, here it is
Okay.
continuous.
So this is the graph for what?
Yeah, this this is the previous one is the graph for x2 plus x square.
So what? I can't hear you. Your voice is
Yeah, wait a
breaking.
second.
Okay. Yeah. So now I could hear that. It's fine.
Yeah, it is one thing. Can you guess what function is this? Hmm?
Uh, X is equal to Y, or like, no, it's not X is equal to Y. No, I don't know.
They are like steps, right?
Right.
It is a step function. What is this step function? Now let's just study this. So take any value over here, 0.5. We'll take 0.7, anything. Okay.
Okay.
What is f of 0.7 in this?
F
Means
of
corresponding
0.
f of 0.7 means when x is 0.7, what is the value of y? That is the meaning of this. Okay.
Right. Okay. That is that also 0.7?
See this, when x is 0.7,
Oh,
this
okay.
red
X
color
is
lines, this
yeah.
red color line is the y values, right?
Right.
What is the value of y when x is 0.7?
Oh, is it? Oh, it's 0. It's 0. Okay. Okay.
It's 0 itself.
Yeah. Right.
What is f of 1.8?
1.
F of 1.2?
It's still 1, right?
F of 2.4?
Or 2.
Means when you observe this clearly, you are getting only the 0.7 is a decimal, 0 is the whole value, whole part, 7 is the decimal part, right?
Right.
Means when you are giving a decimal number, always it is giving the whole part, 0, 1, 1 itself, 2. Okay. Means
Okay.
it, this is, the name of this is called step function because they named it after drawing the graph. Okay.
Okay.
Actually, the name of this is greatest. Wait, spelling. Greatest whole value function. Okay.
Okay.
Means whatever the decimal it may be, always it gives the greatest whole value of that one. So in 1.8,
Yeah.
so the whole number is 1.
1.
Generally, you can, instead of greatest, also just you can take the whole value also. It will give 1
Yeah.
itself. If you
Okay.
input as 2.4, it gives the answer as only 2. Means it gives
2.
only the whole part.
Whole value.
Okay.
Okay.
It is also the greatest whole value function or step function. Okay.
Okay.
And there are, how to denote this step function. Step function is denoted by square brackets. Okay. This is the
Okay.
step function. Okay.
Okay.
Means step, if anywhere in max, if you see this step of,
It's a step.
you have to read it as step of 2.1. The value of step of 2.1 is
Okay. Oh,
what is the step
2.1
of
is
2.1? 2.
2.
Step of 4.9,
Would be 4, right?
it is 4. Step of 5.986,
5.
it always gives the whole value.
Whole
Okay.
value.
Now we know about the step function, right?
Right.
Now we have to
Oh,
tell.
so do we don't write F in front of that? We just
Oh,
write it as
this, no,
bracket.
step. Whenever there is bracket means it is step. That's it.
Okay.
Not F. F you have to represent when you don't know what function it is. Okay.
Okay. Okay.
F is the general notation of function.
Okay.
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 It is just the general notation. That's it. Means here the f of x equals to step x. Okay.
Okay, sir.
Got it?
Yeah.
Now, the question why you are studying this step function and all is because you are studying limits. They will ask whether the limit exists at limit extending to 3 of step x. Simple. Okay.
Okay.
Now what we have to do? We have to take the left hand limit and right hand limit, right?
Right.
So first we will do the left hand limit. So limit extending to, as we discussed before, left hand limit is written as 3 minus, correct?
Right.
Of step x. What is the left hand limit of x when extending to 3 minus? Means the left side of 3. When the we know the value of the graph of step x, right? Now we will draw it.
Right.
We will, let's see. This is 3. 3 minus means this side. What is the value of y?
So what is the value of y when x is at 3, right?
3 minus means before
Oh,
3.
3 minus. It's 3. It's 2. It's 2.
It's 2. Now we will do right hand limit. Limit extending to 3 plus, correct? Of x
Right.
itself. It is right side of 3. What is the value?
3.
3. Is left hand limit
Oh,
equal
so
to right
limit of
hand limit?
no.
Is not equal to right hand limit. So it does not exist. Okay.
Okay.
This is the step function. Remember this. Step function means always it gives the whole value, and this is the graph of this.
Okay.
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 No. I think you know about this modulus function also.
Modulus function. Oh yeah, it just gives the magnitude, right?
So what is the denotation of modulus function?
Oh, I don't know that.
Okay.
Oh, is it a bar on top?
Yes. And a bar on the top is a vector.
No, no, no. No. Oh, sorry. 2 bars on the side. Sorry.
Yeah. This is same as we studied in vectors. Magnitude
Yeah.
is denoted by this modulus, right?
Right.
So f of x is mod x. And how the graph will be for modulus function?
I don't know.
No, you know it.
It's
Just you
always
have to
positive,
think.
right? So
It's always positive, right? Means
yeah.
f of x is x, correct?
Right.
F of minus x is also x. That is the meaning of this.
Right. Oh, okay. So is it like a straight line passing through origin?
So so divide this into two parts. F of x means this is the positive part, right? It is same equal to x
Right.
equal to y graph. So
Yeah.
this is the x equal to y line. Right.
Oh.
This is the x equal to y line, right?
Right.
Now when you come to negative side, there also x equal to y,
Hmm.
means it is not the
But
straight line.
so it's only
This
positive
is,
values, right?
that's why this one.
But so how will it be in the negative also?
No, f of minus x. It's not in negative. See here. The value of x is negative, but not the value of y,
Right.
right?
Oh, okay. Yeah, yeah, yeah. Got it. Got it.
When
Yeah.
x is minus 1, it is 1 itself.
Hmm.
When x is
1.
minus 2,
Right.
it is 2 itself,
Hmm. Right.
right? So
Yeah.
this is the modulus function. It looks like v. Okay.
Hmm. Okay.
This is the modulus function. Then we can calculate the limits directly. And we know it is a continuous function, right? There is no
Right.
break in between this. So if you know how to draw a graph and there are no breaks, then limit exists. That's it.
Okay.
Because wherever you take, if you take over here, left hand side value we have, right hand side value we have. When hn is
Hmm.
0, it comes to this value itself, right? So
Right.
that's why the limit exists.
Okay.
The main theme is just you have to know the graphs, because these graphs are useful when we go in further. So this one, f of x is mod x and f of x is step x. These two functions you have to know. Okay.
Okay.
Then the same thing we will use it in limits. That's it.
Oh.
Okay. That's it. This is the derivatives. We practice the combination of problems in derivatives. What all we can get. We will do all the combinations directly. And it is pretty simple. Once you know how to do it, then it doesn't matter how many functions, how much difficult it may be. It is just one step problem. Okay.
Okay.
Okay, then that's it. And practice the formulas. Practicing means just you have to remember the formulas. I mean,
Okay, sir.
and if possible, just remember this, because it is useful in solving trigonometric limits. Okay.
Okay.
I think today we didn't remember any formula. We didn't do any formula, so this one you have to remember two formulas in this. They are called compound angles. That's it. Sine of a plus b. Okay.
Okay.
Sine a cos b plus cos a sine b.
Okay.
Okay. Now the same thing follows for sine of a minus b. Sine a cos b minus cos a sine b. Means these two formulas are one itself. I can write plus or minus, plus or minus. That's it. Right?
Okay.
No, this is first formula and second formula. Cos of a plus b. Okay.
Okay.
Cos a cos b. Here it is minus sin a sin b. Okay. Cos of a minus b. Cos a cos b plus sin a sin b. It is same as the opposite of this. If it is plus or minus, it becomes minus or plus.
Okay.
You have to remember these two formulas. And today, explicitly, without knowing, we read one formula in the problem itself. That is cos A minus cos B, right?
No, so cos A plus cos B.
Cos A plus cos B.
Yeah. I think so. Yeah, we did cos A plus cos B.
Cos A minus cos B.
Oh, sorry. Yeah. Yeah, cos A minus cos B, sorry.
Okay.
Yeah.
So cos A minus cos B is what we discussed. What is the answer?
2 sin B plus A by 2. Plus, is it plus?
Right.
2 sin B minus A by 2.
2 sin B plus A by 2 sin B minus A by 2. That's it.
Sin B, yeah.
It's not plus, it is multiplication over here.
Yeah. Okay.
Means this total is 1 sin of B plus A by 2. This second sin of B minus A by 2. Okay. These three formulas we have to remember for today. Okay. That's it. So here A, what are these A and B? They are angles. That is whether it can be in terms of x and x, right?
Right.
Suppose 35 and 60. They are just angles. That's it.
Right.
Okay. When we do this trigonometry there, we will study this angle number. Here, just remember this is functions in x. That's
Okay.
it.
Okay.
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 And you have to identify the difference whether sine of a plus b is the total a plus b is in angle or only a is in angle, like here. Okay, means
Oh. Oh.
sine of a plus b, sine a plus b. There is a difference between these two. Okay.
Okay. Okay.
Sine of a plus b means the total angle is a plus b over here. Okay. Here,
Okay.
just a is the angle, b is just a constant. It can be any number. It doesn't matter. Here only
Okay.
a is in the angle, that
Yes.
is theta. The only means you have to see the brackets. That's it. Whether the brackets is for this angle or only for this theta, like this. Okay.
Okay.
This and all again, obviously, we'll discuss in this when you're doing this trigonometry.
Okay.
But these are the three formulas that you have to remember for today. Okay. Noted?
Okay, sir. Yeah.
Yes. And that's it. Okay.
Okay, sir.
And try
Thank
to
you.
do that limits
I,
that I sent to your father.
yeah. I'll check with my father.
Yeah. Okay.
Okay. Thank you,
Yeah.
sir.
Okay. Bye.